Welcome to the click. Let's discover exponents rules, and this is part 2. Starting with the fifth rule, when both the base and the exponent are equal, you may apply either of the previous exponent rules. So up until here, we've learned two rules. One rule talked about when the bases were equal, and one of them talked about when the exponents were equal. If both the base and the exponent are equal though, at that time we can apply any of the rule. The rule 1 talked about this, the same base, we can add the exponents, right? And rule 2 talked about the other thing, the same exponent. At that time, we are going to multiply the bases. So for example, I have 3 to the power of 2 times 3 to the power of 2. Applying the first rule in here right now, it's going to be 3 to the power of 4. And this one, 3 to the power of 2 times 3 to the power of 2, it's going to be 3 times 3 to the power of 2, which will be 9 to the power of 2. And guess what? 3 to the power of 4 and 9 to the power of 2, both of them are equal. Because 3 to the power of 2 equals 81, and the same with 9 to the power of 2. This is why this rule works. The next one, exponent to exponent. This is a very, very popular rule, and it talks about when an exponent is raised to another exponent, multiply the exponents. So I have, for example, x to the power of m all to the power of n. This will equal x to the power of m times n. I have, for example, a to the power of 2m all to the power of 3n. This will be a to the power of 2m times 3n, which equals a to the power of 6mn, right? Whenever you see one exponent to another exponent, when you see one power that has power, then you can multiply the powers. The seventh rule, changing the order of exponents. We had this rule, and it has commutative property. If we change the order, the exponents won't change, and the result won't change. So let's see it again. I will have a to the power of 3n this time, all to the power of 2m. This will equal a to the power of 3n times 2m, which will equal a to the power of 6nm. Do you know why this works? Because multiplication has commutative property. And when we multiply the exponents, it's the same as multiplication. It doesn't change, right? So that's why, because multiplication has commutative property, changing the order of the exponents doesn't matter. Going for the eighth rule, simplifying the exponents. If the same exponent appears on both sides, you can simplify the exponents. Okay? So I have, for example, x to the power of p equaled to y to the power of p. This will be x equaled to y. I simplified p and p, I removed them because they were the same. And the same with this one. X to the power of m all to the power of p equaled to x to the power of n all to the power of p. This will be the same as x to the power of m equaled to x to the power of n. I again removed p's in here. Let's have an example. 2 to the power of 15 equaled to x to the power of 5. This will be 2 to the power of 3 equaled to x. Do you know why? Because I found their GCF, these two numbers GCF. You know how simplification works, right? We find the GCF and then we divide both of them by their GCF. So their GCF were 5, so that's why I divided them by 5, and it will be 2 to the power of 3 equaled to x to the power of nothing, x itself. And yeah, this is the 8th rule. The 9th rule. Powers of negative numbers. When the base is negative, the sign of the number depends on whether the exponent is even or odd. So I have the first rule, even exponent. If the exponent is even, the result is positive. Minus x to the power of 2n, this will be x to the power of 2n because 2 is even, right? Let's do an example. So I have minus 2 to the power of 4. This will be the same as 2 to the power of 4, which will be 16. Why? Because the number is even. Why? Again, because let's see it this way. So minus 2 to the power of 4, this literally means minus 2 times minus 2 times minus 2 times minus 2. Minus 2 multiplied by itself 4 times, right? And this will be 16. Do you know why? Because not only the number, which is 2, will be multiplied by itself, but the symbol will also be multiplied by itself, okay? Both the number and the symbol will go to that power and will be multiplied by themselves by the number of the power. So 2 times 2 is going to be 4. And minus times minus is going to be plus, okay? Plus or positive times negative, it's going to be negative. And negative times negative, it's going to be positive, okay? So that's why at the end we have a positive symbol. So that's why, 16 will have a positive symbol. And the second rule, if the exponent is odd, the result is negative, okay? So I have, for example, again, minus 2 to the power of 3. This will be minus 2 to the power of 3, which will be minus 8. And you know why? Because, at the beginning it turned positive, and on the third part, it turned into a negative symbol. So that's why if you have an even exponent, then the sign will be positive. But if you have an odd exponent, at that time the sign will be negative. Please keep this in mind. We're done. Thank you for being with me. Sources page.